The town festival glows under thick, creeping fog. Laughter and music fade into whispers. A local politician vanishes without a trace. Fairground rides, food stalls, and lost items tell a silent story. Each clue a step closer to the truth. Join me now. Let's uncover what really happened together.
Hi, welcome to this crime case. Let's solve this mystery together. We'll use data to uncover the truth, step by step. Ready to play detective? Let's begin. First, we need to gather our evidence. We'll load 3 key datasets: fairground rides, food stall purchases, and lost and found check-ins. Each one could hold clues about Linda's last movements. Let's get our data ready for investigation. First things first, we need our investigative tools. So I'm importing Pandas as PD, which lets us handle big tables of data, and from datetime, I'm grabbing the datetime class. Think of Pandas as our digital magnifying glass, and datetime as our way to track exactly when things happened. With these, we're ready to dig into the fairground mystery. Let's start by pulling up the ride records. Here I'm creating a variable called rides. That's just a name we'll use to store our data, and I'm using pd.read_csv to read in the file called datasets fairground_rides.csv. This gives us a table of everyone who went on each ride and when. Every row could be a clue. Maybe someone was on a ride when the crime happened, or maybe not. Next, I'm loading in the food stall purchases. Same idea, I'm making a variable called food and using pd.read_csv to open up datasets food_stall_purchases.csv. This table tells us who bought snacks and when. Maybe someone grabbed a suspicious snack at just the wrong time. Let's keep that in mind. And finally, let's check the lost and found. I'm reading in datasets lost_ and _found_ check-ins.csv into a variable called lost. This file logs every time someone checked in a lost item. If something important went missing, this is where we'll find the first hint. With all 3 datasets loaded, we're ready to start connecting the dots. Now let's dig deeper. We'll take a quick look at the first few rows of each dataset. This helps us understand what kind of information we have. Every detail could be important for solving the case. Let's start by printing out the rides data. In Python, when you use the print function, just like this, print, open parenthesis, rides, close parenthesis, you're telling the computer to show you whatever's stored inside the rides variable. Think of a variable as a labeled evidence bag. In this case, rides might hold a list of all the taxi trips taken the night of the crime. By printing it, we're laying out all those journeys right in front of us, looking for any unusual detours or late night drop-offs. Next, let's print the food variable. Again, print, open parenthesis, food, close parenthesis. This is Python's way of saying, hey, show me what's inside the food evidence bag. Maybe this holds a list of all the meals ordered at the party. We're looking for anything out of the ordinary, like a suspicious midnight snack or a meal sent to a room that shouldn't have been occupied. Every detail counts. And finally, let's print the lost variable. Same idea, print, open parenthesis, lost, close parenthesis. Here, lost could be a list of items reported missing after the incident. By printing it, we're putting all those lost objects on the table, searching for connections. Maybe there's a missing key or a phone that vanished at just the wrong time. In Python, print is our flashlight, and variables are the boxes we're opening one clue at a time. We can see each dataset has time-stamped records, but to compare events, we need all the times in the same format. This step is crucial for building an accurate timeline of Linda's movements. Alright, let's take a closer look at the timeline of events. Here, I'm looping through 3 different datasets: rides, food, and lost. Each one's like a different witness statement. For each data frame, I'm converting the time column from just plain text into an actual time object using Pandas. That way, we can compare times precisely, down to the minute, and spot anything unusual in the sequence of events. In Python, a for loop lets us repeat the same action for each item in a list, so we don't have to write the same code 3 times. Now, let's focus on Linda Park herself. We'll filter each dataset to see only her activities. This will help us trace her steps on the night she disappeared. Let's start by setting the scene. We're looking at Linda's ride activities. This is where our investigation begins. Here, I'm creating a new variable called Linda_rides. In Python, a variable is just a name we use to store information, like a folder where we keep related clues. I'm telling Python to look at our rides data and filter it down to only the rows where the person's name is Linda Park. So we're zeroing in on every ride Linda took. Nothing else gets through this filter. Now let's take a look at what we found. By typing Linda_rides, I'm asking Python to show us all the rides Linda Park took. This is our first real look at her movements, and maybe, just maybe, we'll spot something unusual. Look closely at this clue. Linda was on the Ferris wheel at 1910 and again at 1925. Then she rode the carousel at 1930. Let's see what she did next by checking her food purchases. Let's start by jotting down a note. We're about to dive into Linda's food purchases. This will help us keep our investigation organized as we sift through the evidence. Alright, here's where the detective work begins. I'm creating a new variable called Linda_food. In Python, a variable is just a name we give to a piece of data so we can use it later. I'm telling Python, look at our big list of food transactions and filter it down to only the rows where the customer's name is Linda Park. That way, we're zeroing in on just Linda's purchases. Nothing else gets through. Now, let's take a look at what we've uncovered. By typing Linda_food, we're asking Python to show us all the food records linked to Linda Park. This is like laying out all her receipts on the table. Let's see if anything unusual jumps out. Interesting. Linda bought a hot dog at 1905 and cotton candy at 1933. Notice, the cotton candy was after her last ride. Let's see if she visited the lost and found tent next. Let's start by setting the scene. This line's just a note for us. We're about to dive into Linda's lost and found check-ins. Think of it as opening up her personal file in the evidence room. Now here's where the detective work begins. I'm creating a new variable called Linda_lost. In Python, a variable is just a label we use to store information, like putting evidence in a folder with Linda's name on it. We're telling Python, look at our big list of lost items, but only keep the ones where the person's name is Linda Park. That's what this double equal sign does. It checks if each record matches Linda. So we're filtering out everything except Linda's activity. Let's see what she's been up to. Alright, let's take a look at what we found. By typing Linda_lost, we're asking Python to show us all the records we just filtered. Every lost and found check-in tied to Linda Park. This is like spreading her evidence out on the table, ready for us to examine for clues. This is where things get interesting. Linda checked in an umbrella at 1900 and a purse at 1936. That purse check-in is the latest activity we have for her. Let's build a timeline to see the full sequence of her movements. First things first, we're bringing in Matplotlib.pyplot. That's our toolkit for drawing charts and visual clues. Think of it as our detective's sketchpad, ready to help us visualize the timeline of the crime. Here, I'm setting a variable called date to 2020-1 gauss 1. By giving every event the same dummy date, we can line up all the times on a single day. It's like putting all the evidence on one big board, so nothing slips through the cracks. Now let's define a function called toUnderlineDT. In Python, a function is just a reusable set of instructions, like a detective's routine. This one takes a time string like 14:30 and combines it with our dummy date, turning it into a full datetime object. That way, every clue gets a precise timestamp, making it easier to spot patterns. Alright, time to focus on Linda's rides. We're about to standardize her ride records so they fit our master timeline. Let's see where she was and when. Here's where the magic happens. I'm taking Linda underline rides and using the assign method to add new columns. First, we convert each ride's time to a date time using our toUnderlineDT function. Then, we label every entry as a ride event and store the ride's name in a detail column. Finally, we keep just the time, event, and detail columns, so every ride is logged in a neat, consistent format. This is how we make sure every clue lines up perfectly. Next up, let's do the same for Linda's food stops. We want every snack and meal to show up on our timeline. You never know when a bite to eat might hide a clue. Just like before, we're taking Linda underline food and assigning new columns. We convert the time, label each as a food event, and record the stall's name in the detail column. Again, we keep only the essentials, time, event, and detail. This way, every food stop is tracked, just like the rides. Now, let's not forget the lost and found events. Sometimes what's missing tells us more than what's there. We'll standardize these records too, so nothing gets overlooked. Here, we process Linda underline lost. That's her lost and found activity. We convert the times, label each as a lost and found event, and note the item in the detail column. By keeping just the time, event, and detail, we make sure every lost item is logged right alongside the rides and food stops. Alright, now for the big moment. Let's pull all these clues together into one master timeline. This is where we start to see the full picture. We're using pandas.concat to combine the rides, food, and lost events into one big table. Then we sort everything by time so the events play out in order, just like rewinding security footage. Finally, we reset the index to keep things tidy. Now every clue is in place, ready for us to spot connections. And here it is, the final timeline table. Every ride, every snack, every lost item, all lined up. Let's scan through and see if anything jumps out. First, let's set the stage for our investigation. I'm creating a new figure with Matplotlib, making it nice and wide, 9 by 5.5 inches. This gives us plenty of space to lay out Linda Park's timeline so we don't miss a single detail. Now I'm setting up a variable called y. That's just a list of ones, one for every event in our timeline. Think of this as a straight line running across our chart, like a string of clues all lined up. In Python, creating a list like this helps us plot each activity at the same vertical level, making the timeline easy to follow. Here comes the first big reveal. I'm plotting each event from our timeline. On the x-axis, we've got the exact time of each activity, and on the y-axis, we're using those ones to keep everything in a neat row. Each event gets a little circle marker so we can spot every moment Linda was accounted for. Let's make sure we don't lose track of what happened when. I'm about to annotate every point on our timeline with a short label, so every clue is clearly marked for us to investigate. I'm using a for loop here. That's a way to go through each row in our timeline one by one. For every event, I'm grabbing the time, the event name, and the details. This lets us break down the night step by step, just like a detective reviewing the evidence. Inside the loop, I'm building a label for each event. I'm using an f string. That's a Python trick for combining text and variables. The label shows the time, the event, and a quick detail all in one line. This way, every clue is easy to read, right on our timeline. Now I'm placing each label onto the chart right where it belongs. I'm rotating the text a bit so it doesn't overlap, and I'm making sure it lines up nicely above each event. This makes our timeline not just informative but easy to scan for anything unusual. Let's highlight something important. I'm about to mark the last known activity. This is the final point where Linda was seen, and it could be crucial to cracking the case. To do that, I'm finding the latest time in our timeline. I'm using the max function to pull out the biggest or latest timestamp. This tells us exactly when Linda's trail goes cold. With that time in hand, I'm drawing a dashed vertical line on the chart. This marks the moment of Linda's last known activity, a clear signal for us to pay close attention. Right next to that line, I'm adding a label, last known activity. I'm placing it just below the line so it's easy to spot. This way, everyone knows where the timeline takes a mysterious turn. To keep things clean, I'm hiding the y-axis ticks. Since our timeline only cares about the order of events, not their vertical position, this makes the chart look less cluttered, letting the clues stand out. I'm labeling the x-axis as time. This helps us and anyone else looking at the evidence know exactly what each point represents. Let's give our chart a proper title, Linda Park Timeline of Activities. This sets the scene for our investigation so everyone knows whose story we're unraveling. Before we reveal the timeline, I'm calling tight layout. That's a Python function that automatically adjusts the spacing so nothing gets cut off. It's like tidying up the evidence board before the big reveal. And finally, I'm showing the plot. Now, the entire timeline is right in front of us. Every event, every clue laid out for us to examine. Let's see if anything jumps out. From the timeline, we see Linda's last recorded activity was at the lost and found tent at 1936. That's after her last sighting at the Ferris wheel. So she was still moving around after 1930. Now let's see who else was nearby at the lost and found tent around that time. Looks like our first clue is just the word lost. Look closely at this clue. Between 1934 and 1936, Eli Turner, Sam Patel, and Linda Park all checked in items at the lost and found tent. They were likely in the same place, just minutes apart. Let's check if any of them were with Linda earlier on the rides or at the food stalls. Alright, let's set the scene. We're trying to answer one big question. Who rode with Linda on the Ferris wheel at 1925? This is the moment that could crack the case wide open. Now I'm typing out a filter to zero in on just the Ferris wheel rides. Here we're saying, show me only the rows where the ride column equals Ferris wheel. This is how we narrow down the crowd and focus on the suspects who were actually on that ride. It's like flipping through the guest book but only stopping at the Ferris wheel page. Here's our big reveal. At 1925, Linda Park and Sam Patel were both on the Ferris wheel. Sam also appears at the lost and found tent just before Linda's last check-in. Based on the data, Linda's last known location was the lost and found tent at 1936. Sam Patel and Eli Turner were both there within minutes. Sam Patel is a key person of interest in this mystery. Great detective work. Thanks for helping solve the case.